Today we will be talking about various tips and tricks to help you with math competitions. The first topic we will be covering is the Pythagorean theorem. It states that for a triangle with sides A and B and hypotenuse C, a squared plus b squared equals c squared. This is helpful for finding the third side when given two sides of a triangle. Listed here are triples of triangle sides that work with the Pythagorean theorem. Memorizing them helps you save a lot of time in competitions. Now we will go over how to solve percentage problems faster. Let us see how to solve 4% of 75. One way to solve is to do 75 is 3/4 of 100, and 4% of 100 is 4. So that means that 4% of 75 would have to be 3/4 of 4, which is 3. And that is true that 4% of 75 is 3. However, this is fast, but let's see if we can do it faster. So, here's one way to do it faster. X% of y is always equal to y% of x. So that means 4% of 75 is equal to 75% of 4. And it is easier to calculate, because 75% of 4 is just 3/4 of 4. So that means that 75% of 4 is 3. And we get the same answer each way, but we do it much faster in the second method. Now let us move on to the next problem. Finding 128% of 625. So it is hard to solve using the method from before even if we do 625% of 128. So there is one method that we can use which will make it easier. So I covered that x% of y is equal to y% of x, but x% of y is also equal to x over 10 multiplied by y over 10. So 12.8 multiplied by 62.5. And then when we calculate this, it is the same as 128% of 625. So then when we do this, it equals 800. And that if you check 128% of 625, it is 800. And this works for all numbers. So those are the two percentage tricks. Now let's move on to the next trick. Now we are going to do two combinatorics problems. Here I will teach you many fundamental formulas that you can use for problems on the Mathcounts and AMC8 tests. So how many ways are there to give 9 identical cookies to 3 people? Well, you might think it would be 3 to the power of 9, but that would be incorrect, although it would be a reasonable guess. Let me show you a formula that you can use for this. This is called the stars and bars formula. So it is how to give n objects to k minus 1 bins. So in this case it would be 9 is n and k is 3. So k minus 1 would be 2. Because if you're giving it to 3 people, imagine they're separated by dividers. and there will be two dividers, not three. So that is why it's k minus 1. So now that we have n is 9 and k is 3, the formula is n plus k minus 1 factorial over k minus 1 factorial multiplied by n minus k minus 1 factorial. N plus k minus 1 factorial. And then minus k minus 1 factorial. So this is the total number of objects factorial minus k minus 1 factorial into the total of number of objects minus the minus 1 factorial. So this would be 11 factorial over 2 factorial into 11 minus 2 factorial, because it simplifies to 11 choose 2, which is 55. And this formula can be used for many similar problems where you give n objects to k minus 1, like people or bins. So the next problem is, how many ways can the letters Mathcounts be arranged so that the letters UN stay together? So this is a simple combinatorics problem where we treat UN as one object. So if we count the total number of objects, it would be 9 objects, because M, A, T, H, C, O, U, N, T, and F. So now we might think it would be 9 factorial, because 9 ways to arrange 9 factorial ways to arrange 9 objects, but that would be wrong. It would work if there are no repeating letters, but as you can see here, there are two t's that are repeating. So we have to divide by 2 factorial, because there are 2 factorial ways to arrange two t's. And we don't want repeat cases. We don't want to overcount. So the equation we have now is 9 factorial over 2 factorial. And then this is a very large number, but when we calculate it, we get 101,440. So here I taught you two formulas for different problems. One for putting n objects into k minus 1 bins, urns, whatever you'd like to call it, and how to do factorial problems with overcounting. So these should help you solve problems faster and get them correct. Now we will do problems from the Mathcounts sprint round. These are not the exact problems, but they are very similar to what have appeared before. The first problem is, by swapping two digits in the number 123457, Jack gets a number 1980 more than the original. What is the sum of the two digits that were swapped? Now your first instinct might be to add these two numbers, and then you'll see what two numbers would swap. But this would actually take too much time, since the sprint round goes by very fast and you do not have much time for problems. So instead, what we will do is, let's write the number here, and we are going to add 1980, but in a more efficient way. So we know that the number still must be 6 digits long because you only swap two digits. So we add 7 plus 0 and get 7. Then add 5 plus 8 and get 3. And we can already see here that he has swapped 5 and 3. Because where 5 was supposed to be, 3 is now there. So we can already, without adding the rest of the digits, we already know which two numbers were swapped. And then the new numbers 125,437. So we just add 5 plus 3 and get our answer 8. So this goes by a lot faster than adding the whole number to 123,457 and would save us a lot of time. Now let's go to the next problem. What is the probability that it will be sunny on both Wednesday and Friday if there is a 60% chance of rain on Wednesday and a 30% chance of rain on Friday? So we see that it says that it will be sunny on both Wednesday and Friday. So and both in probability means that we have to make both of the events occur. So we multiply probabilities. So like if it's sunny on Wednesday, that's event A, and if it's sunny on Friday, that's event B. And or in a probability means that they're independent events, either one can occur. So that place we would add probabilities because we're increasing the chance that one event would occur. So 60% equals 0.6 and 30% equals 0.3. We'll use this just so we can multiply. We just write down what and both and or mean. Multiply probabilities and add probabilities. So now we know we have to multiply probabilities, so 0.6 into 0.3 will get us 0.18. And that is our answer, that there's an 18% chance that it'll be um, sunny on both Wednesday and Friday. And so these are actual problems from the sprint round test to see how fast you would solve them and how you would think to solve them. So if you find that you're using your method, you can find more methods to solve them faster, and that should help you on the sprint round. After this, we will do challenge problems. And one of the I can recommend that you can do besides my challenge problem is to find out what is the probability that it will be sunny on either Wednesday or Friday. And keep in mind that it'll be a little more different than adding probabilities. There's a formula that I'll go over next that you can use for it. Now we will move on to the challenge problems. I will have 4 challenge problems. If you complete at least 2 of them, I will give you a shout out in the next video. Thank you for watching this video. I hope you enjoyed it. These are the challenge problems for this week. If you complete at least 2 of them and are one of the first 10 people to do so, I will give you a shout out at the end of my next video. Thanks for watching. That's all for this video.